have gone down very quickly. Next, the phone lines. And finally, the last television and radio broadcasts would end. Starvation would probably begin in the dense cities of Asia, especially with no air conditioning at food warehouses. Within a few weeks of a complete blackout, almost all the world's cities and suburbs would be unlivable. There would be fighting, pretty desperate for food and fuel, and with a world population of 6 billion, few people would have a chance of surviving. But what if it were not only our supply of electricity that failed? What if the very existence of electrical forces stopped? All the Earth's oceans would gush upward and evaporate as the electrical bond between water molecules broke apart. DNA strands within our body would no longer hold together. Any air-breathing organism that was still intact would begin to suffocate, for without electrical attraction, the oxygen molecules in air would bounce uselessly off the hemoglobin molecules in blood. The ground itself would open up and begin to melt as the electrical forces that hold the silicates and other substances of our planet together let go. Mountains would collapse into the voids left where the continental plates had torn apart. In the last moments, a few living beings would see the sun itself switch off, as our stars' electrically carried light abruptly stopped and the world's very last day turned to night. Why doesn't any of this happen? The force of electricity is very powerful and has been operating non-stop for more than 13 billion years. But it's also utterly hidden, crammed deep within all rocks and stars and atoms. The force is like two Olympian arm wrestlers whose struggle is unnoticed because their straining hands barely move. There are almost always equal amounts of positive and negative electric charge within everything around us, so well balanced that although their effects are everywhere, their existence remains unseen. For long eons it remained like this, as galaxies evolved and planets formed, as continents and trees and grasses appeared on Earth. Occasionally, there must have been brief sightings in the past. Our Australopithecine ancestors would have noticed abrupt bursts of lightning, as would early humans. But as soon as it appeared, this force would quickly have returned to the invisible realm from which it had come. For most of history, humans simply stumbled around it unaware. In one of his writings, Isaac Bashevis Singer imagines a peasant in medieval Ireland who takes off his flaxen tunic one night and notices bright sparks leaping from the fabric. If Singer's peasant called in the village priest and other wise elders to see it happen the next night, they would be unlikely to notice anything. Static electric sparks usually appear only in dry air, and Ireland is wet. No one would believe what he'd seen. No one would have been able to examine it further. Even in dry desert countries, dust or sand could make scattered sparks seem to appear and disappear in purely random ways. There were many fragmentary efforts to penetrate this hidden world, from classical Greek times on, but even into the mid-1700s there was little true knowledge. The breakthrough came with the work of a conveniently vain Italian investigator, Alessandro Volta, in the 1790s. It would be a great honor, he felt, to locate the portal from which this mysterious electricity emerged. And, after much effort, he realized where he should search. He found that if he pressed a coin-shaped copper disc against one side of his tongue and a zinc disc against the other, and then touched the tips of the two coins together, a tingling sensation would race across his tongue. He'd located the world's first steadily operating battery in his mouth. Volta soon found that any two metals would do the trick, so long as they were separated by a small amount of saliva, brine, or other corrosive liquid. He didn't know why this worked, or how the brine was making extra electrons appear on one of the metals.